Alright, for this one we have probabilities with not and or type of statements. For number 1, what is the probability of not getting a 6 when drawing one random card from a standard deck of cards? So remember, for these not statements, you're really doing 1 minus the probability of drawing a 6 here. So remember, in a deck of cards, there are 4 different suits, so there's 4 6s out of the 52 cards in the deck of cards. So that means here, if you subtract those, if you have it as a fraction, you'd have 48 out of 52. That would not be a 6, which then simplifies to 12 over 13. And for these probabilities, like before, you can either simplify it as a fraction like I did here, or if you prefer, you could do 12 divided by 13 to get it as a decimal, or you can then convert that decimal to a percent. As long as it's either simplified, a decimal, or a percent, you'll get that correct there. For number 2, what is the probability of rolling a 3 or a 4 when rolling a single die? So if you're rolling just one die, a normal 6-sided die, to get a 3 or a 4, that would be 2 possibilities out of the 6 different sides, which then would simplify down to 1/3. Once again, you can either leave it as that simplified fraction, or you can convert it to a decimal or a percent there. In this case, you didn't have to worry about subtracting off anything that they have in common, because you can't roll both a 3 and a 4 at the same time whenever you're rolling only one die. So that's why you just add together the possibilities of each to get the 2 out of 6 and then simplify. Whereas for number 3, the next one, what is the probability of drawing an ace or a red card from a standard deck of cards? So here there are, once again, 4 different suits. So you'd have 4 aces out of the 52 cards, plus, and then half the cards are red, half of them are black. So we'd have 26 that are red cards out of the 52 cards, minus, and then make sure to take out the number of aces that are also red cards. So remember, half of those aces are going to be red, half of them are black. So take out the 2 that were red aces, so you're not counting them both as aces and as red cards. We don't want to double count anything. So then whenever you go through and combine those together here, we'd get 28 out of 52. And then if you simplify 28 divided by 52 there, you would get 7 over 13. Once again, you can either leave it as a fraction there, or you can convert it to a decimal or percent. Any of those forms would work. If you have questions, make sure to ask like normal.